Hello everyone, and thank you for joining us. My name is Gisela and I will be the host for today's webinar. Before we drop into the content, let me cover a few housekeeping items. At the bottom of your screen are multiple application engagement tools that you can use. All these engagement tools are raisable and movable, so feel free to move them around to get the most out of your desktop space. You can also expand your presentation area and maximize it to full screen by clicking on the arrows on the top right corner. If you have any audio or video issues, you can find some answers to some common technical problems located in the Help widget at the bottom of your screen. Please note that a copy of today's slide deck and additional resources are available in the resources list. Please have a look and download everything that you may find useful. On top of this webinar will be recorded and sent to the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We are here to answer you live into the chat, so don't hesitate to reach out. If we run out of time or we don't manage to answer your questions, we will make sure to follow up later by email. Now, I would like to pass it over to our speaker, Amy.
Thanks, Gisela, for your introduction. My name is Aimi Langberg, and I'm a solutions consultant for Jama Software. To start off today, I have a very special guest to chat with me about systems thinking. David Long is an internationally recognized leader in systems engineering with over 30 years of experience advancing and advocating for best practices across government and commercial organizations. Founder of Vitech and now president of Blue Hole, he has developed industry-leading MBSE methods and tools to help teams navigate digital transformation. As an INCOSE fellow and past president, David will be able to provide the framework for us to reference as we talk about concepts and application today. I'll be back to continue our presentation after the interview. Hi, David. Thanks for taking the time to talk with me. I'm excited for this opportunity.
Pleasure, Amy. So am I.
Great. You've been advocating and teaching about these concepts for a long time. And as organizations move from traditional document-based methods, I have found it really does require a mindset, like a total shift in mindset to be successful. So how do you define systems thinking? And what core principles are the most essential for effective engineering?
Now, I appreciate you starting it that way, Amy, because systems thinking is the thought process that underlies systems engineering. So if you don't go back to the core, you're not going to get the model-based right. So for me, systems thinking is all about focusing on the whole, the big picture, whereas we've been taught analytical thinking, which focuses on the parts in deep detail. So when you're doing systems thinking, you're looking at the whole, at the interactions, at the interrelationships between ideas and concepts, and you're thinking dynamically across time because things aren't static. In terms of core principles that you've got to apply when you're looking at the systems thinking, it's the holism, it's the big picture. As Stanley McChrystal once wrote, you can't understand a part without at least a rudimentary understanding of the whole. You can only make good decisions about the part if you have the context of the whole. Then you've got the interconnectedness, which is ever increasing because of today's technologies, the electronics and software that empower today's products mean that really every piece is interconnected with every other piece. I mentioned that thinking dynamically across time, there are feedback loops. How are things changing? Go back to thinking that we did in school with predator-prey relationships. As prey populations rise, predator populations rise. As predator populations rise, prey populations fall. What are those feedback loops that are going on in our systems? And then the positive idea of emergence and the negative idea of unintended consequence. If you disassemble an airplane, it won't fly. It's only the engines working with the wing to provide lift, working with the fuselage to provide structure, with the controls that will allow you to fly. But then that's the positive emergence. What's the negative emergence, the unintended consequences that we haven't thought of? So those are the core principles that I think of when I start talking about systems thinking.
That's really helpful. And it's kind of, I like these unintended consequences, the idea of mentioning that, because we always talk in engineering about the unknown unknowns. And
Yes.
that's kind of what this goes back to. What are some common misconceptions you encounter about MBSE or the systems thinking approach?
So at the systems thinking level, the first thing that I'll say, and it's not a misconception, but we can fall into the trap, it's the idea that systems thinking is more important than analytical thinking. The reality is that we need both. We need the big picture thinking that looks at the interactions, but also we need to do really good, deep analytical thinking. And the other idea at systems thinking level is that somehow systems thinking is a skill that's limited to the few. I'm a big believer that we're actually born tuned towards systems thinking. If you look at a 2-year-old or a 3-year-old, they will frequently ask why, why, why. What they're trying to do is to connect how things work. They're looking for those interactions, those relationships. Western education actually takes us and makes us deep analytical thinkers. Now, that's good, that's allowed technological advance, but we have to reprime that systems thinking pump. So we all have the capability if we tend to it. If we shift then and look at MBSE as we're implementing SE today, the first myth is that somehow MBSE is different than systems engineering. It's not this different thing. It's a modern approach taking advantage of today's technologies. Second myth would be that MBSE equals SysML or any other notation, any other language. The reality is MBSE is all about leveraging today's digital capabilities, the unprecedented computing power, the unprecedented storage capability that we have to better represent and analyze the systems that we're trying to build. We can be more explicit, more coherent, more consistent, and we can leverage that computational power to simulate before and during the build to deliver better results. So MBSE is just SE done in today's environment with today's technologies.
I like the way you described that because I agree. I've encountered that misconception as well about trying to equate to SysML. It's not about a language, a modeling language. It's about us all speaking the same language as far as, SE goes. And that's what I think MBSE is often trying to bring in, to the technology.
And
Um,
one of the challenges there, Amy, is that systems engineering is still as much of an art and a craft as it is a formal discipline. And so MBSE is forcing us to mature the principles and understand the underlying foundation. And that's why it can sometimes feel like it's different than SE. It's why sometimes SysML can be confused with being MBSE. But if we'll recognize that we're maturing the practice as we go digital, I think that helps the journey.
Yep. And that's one of the big topics all the time is about how do we do these digital transformations.
Yeah.
Um, are organizations doing enough to foster systems thinking as we do move towards, these transformations? Are there simple techniques to get started or ideas you have at the grassroots level?
So I would argue that traditional organizations are not doing enough to really foster systems thinking. A traditional organization is built on an industrial mindset, the mindset that allowed us to do factories. And that's a mechanistic mindset, which says if each of you will do your bit part, then the whole thing will assemble and work. And if we're working simple problems, precedented problems, if we've mastered the design and we're building a million of these cogs, that works. But that's not what we're really doing. We're doing things that are more complicated and more complex. So I think organizations need to promote big picture thinking. I think they need to not only communicate what it is they want somebody to do, but what the context is for that work and what the greater context is for what the organization is delivering. If we seek to understand not only the solution that we're building, but the problem we're trying to solve, that yields fresh insights from the problem space and actually allows each of us as specialists to bring our knowledge to say, oh, that's what you're trying to do. Well, there's this interaction that we haven't thought about. Or have we tried thinking about this? Now, if you go back in time, we had integrated product teams. That's a simple starting point. Empower those integrated product teams with an understanding of context and problem and get them to collaborate across bounds, and you'll get better systems thinking. If we talk about what can I do as an individual, what if my organization is not pushing this? Well, rather than just focusing on the processes that we do, focus on why we're doing what we're doing. What's this problem we're trying to solve? How are we trying to solve it? And then what are we doing? That understanding of larger context, of relationship and dependencies are really important. What you're building, what's it connected to? When you're building what you're building, who are you dependent upon and who's dependent upon you? And the last thing that I'll say here is there's a very simple technique out of business analysis that's helpful here, and it's called SIPOC, SIPOC. And it stands for supplier, understand who's feeding you stuff. Inputs, what are the inputs to you or the inputs to what you're building? Processes, that's what you're doing. That you've got through analytical thinking. Outputs, what are you generating? And then customers or consumers, who's consuming that? And if you individually will think about SIPOC for what you're building and you, how you're building it, you'll be better connected and you'll start to foster at least a systems thinking understanding of your part of the puzzle.
This is great. And you notice I'm nodding a lot because I am in violent agreement with everything, the things you're pointing out. And it sounds like I've encountered some of similar challenges that, you're referring to. Are there any specific methodologies or frameworks within, and you were talking about SIPOC, so maybe this
Right.
kind of fits in with that. Are there any frameworks within MBSE or SC that you think are underused but have more
Yeah.
potential? And that might, as I said, just go right into what you were just mentioning.
No, you're right. It feeds back to SIPOC and things like that. When we get into systems engineering and MBSE in particular, we're going to hear a lot of USIM, object-oriented systems engineering methodology from INCOSE. We're going to hear Magic Grid from Dassault. We're going to hear different organizations with their particular methodology. I tend to go back to the foundational pieces to get started. SIPOC is one. Spade from Cecilia Haskins is another. It focuses us on stakeholders. Who are the people involved? Who have the concerns? P, problem. What problem are we trying to solve? A, analysis. D, we have to make decisions. E, we have to do evaluation. And that's a continuous thing. Or I will go to Hilary Soletto's architecting framework, which talks about the enterprise perspective. What's the real big picture? Operational architecture, what's the capability you're trying to deliver? Then you get into system definition, logical architecture, which I would call behavioral architecture, physical architecture, and decision roadmap. The fundamentals here, when we go to a SIPOC or Spade or Hilary Soletto, it's about recognizing that we need to think in both problem space and solution space. Einstein said, if I had an hour to solve a problem, I'll just spend 55 minutes in the problem space. We want to leap to the solution space. It's about functional and physical thinking. Most engineers in particular are taught to think about the physical instantiation. What are we building? But the functional is what are we actually trying to do? Are we trying to move something? Are we trying to lift something? What's the function, not the implementation of it? And then the other critical idea in systems engineering and all these frameworks is thinking in abstractions. We're not generally taught to think in abstractions. We tend to think at the atomic detail about the nut, about the bolt. Well, systems are so big, we have to learn to think in abstractions and progressive elaboration. And those frameworks help us think in abstractions while also thinking about the interconnectedness.
Right? It's like being able to see that big picture, but also making sure everyone within the project, whether it's stakeholders or whether it's the engineer or someone doing assembly, everyone is kind of interconnected and can see those different views, whether it's
Yeah.
functional, whether it's the physical view. And you mentioned behavioral, which I think often gets overlooked in some of the traditional systems engineering, that whole behavioral piece that really does feed into test cases later and a lot of these other
Yeah.
things that we need to
Absolutely.
commit to.
There's the old saying that you can't see the forest for the trees.
Mhm.
Well, if we want to talk about, break that analogy down for one moment, seeing the forest is the big picture. Each of us is an analytical thinker as doing our job in an organization. We have our particular tree. It helps me to understand the trees around me and my interactions with them. And then we, as analytical thinkers, need to delve deeply into the bark and the roots and
Right.
everything about our given tree. I don't need to know that about everybody else's tree, but I need to know it about mine. And so that's often a very simple analogy for non-technical people. Seeing the forest, it's not seeing the forest or the trees. You have to see the forest and the trees.
That's a really good way to put it. And you're right. That is a way to perhaps make it more clear for maybe the more business minded or even, all of the
Yeah,
different stakeholders.
good.
Um, One last question I'd like to ask you about. This is on everyone's mind, of course. What non-engineering disciplines do you think would benefit from systems thinking? Where could we use this outside of engineering? Or are there current trends you're seeing that could benefit from this systems thinking approach?
Yeah. Well, I think you just hit it when you made that comment about communicating with business.
Mhm.
And I would say that the group that it's most important to understand systems thinking at a deeper level, it's going to be at the business layer, at the leadership and the management layer. They're the context within which we operate and live as we try to solve problems.
Mhm.
Engineering lives in a business context. That's reality. Now, in terms of trends, we're dealing with an explosion in complexities and an explosion in customer expectations. We're trying to do bigger things. We're trying to do more audacious things. The technologies that we use, electronics, software, AI, ML, have a greater complexity. The project teams are more complex. We have so many different disciplines that bring their expertise, and we have to have, as you said earlier, a shared understanding. And we're being forced to deliver solutions faster. The only way we can do that is by having an organization that understands the systems that we're building are all interconnected, which means that we as an enterprise have to understand each other better. We have to understand the work that each of us is doing better. We have to have access to at least top level data about how these things fit together. Conway's law states basically that the products that we build are a reflection of the organizations that design them. And so let me give you a negative example first. If you go back into, there was an article published, I believe it was in Time in 2023, that talked about how rooftop solar, which was deeply incentivized in California in 2000s, with all sorts of financial incentives, was reaching its end of life. All of a sudden, these rooftop solar panels that were intended to be so ecologically friendly were ending up in the waste fills
Yep.
because nobody had anticipated their disassembly. So, are we thinking at a big picture level? Are we thinking about through life? Are we thinking about unintended consequences? I think with the speed that things are moving at this level of complexity, what we've got to seek is continuous learning, agility, adaptability, and that comes from coupling that traditional analytical thinking with just that better systems thinking, big picture awareness at the technical level, yes, as engineers, but at our leadership levels as well. organization, and honestly, society.
Agreed, 100%. And I think we're all taught this in engineering that we need to help advocate for these things to do better for society. And that feeds back into what you mentioned about business. Maybe as engineers, we take, discussions like this, and then we bring them forward. And when we keep trying to advocate for that within our own organizations. So,
Perfectly stated, Amy.
well,
Perfect.
thank you. Okay, David, thank you for taking the time to chat today. I hope you stick around to see the rest of the webinar.
I will. It's a pleasure. Thank you.
Thanks. Today, we're touching on three key topics with an emphasis on how systems thinking and MBSE technologies are interwoven with each. We'll review the definition of systems thinking using insights provided by David Long. I'll give a brief description of what is implied when we talk about model-based system engineering and use the acronym MBSE. And whether you're considering migrating from document-based processes or whether it's something you're implementing already, some strategies to achieve a unified data model ecosystem will be reviewed. And we'll finish with some best practices for leveraging AI and LLMs. Another thanks to David for taking the time to chat with me. No one can explain this topic better than he can. And I especially liked this quote about how we can each contribute to systems thinking. As we